Jung in Korean University of EIA. And today's review lecture will be about the light vectors and the related Schrödinger equation by the electron's movement. And finally, why we use the Schrödinger equation and how we find the electron in the current model of the atom in orbit. So see, we know the light is something bright of the energy, so we can say that this light is a particle that have contained energy. But by the Einstein, he showed that light is not only the particle but also a wave function or something that have frequency. So we can say that the light is some sinusoidal energy is wave. So in modern theory of the psychology, the light is the electromagnetic field, which means for the y-axis, the electric field goes to the s-field and tilting by the 90 degree, the magnetic field sail may follow the electric field by the vertical method. So, see, along the y-axis, the electric field will propagate, and along the z-axis or x-axis, the magnetic field will follow the electric field. So, this is why we call the light as the electromagnetic field or the wave function, or just a wave that have frequency. More simply saying, to the two-dimensional, the light can be stated as the wave that have sinusoidal function. Of course, it will be changed if there is some index changed by material that have light entered or by something other effect like scattering, reflection, or just by the group velocity that if the light meet another electron wave or magnetic wave or light and get interference, destructive or constructive or anything else. So the group velocity or the wavelength will be changed. So to back in the point, we can say the light is particle and wave. So what does determine the light intensity, which means brightness and the energy? What color or how energy the light is containing? So for intensity, how it is bright will determine how many photons is contained in the light wave. And for frequency, how fast it is tumbling or bubbling when propagating. So let's see. I have 1 punch for a second and 4 times for a second. Which can be more strong if they have same energy propagated? I will choose the latter one. So, more higher frequency, the more higher energy you have. And then, for more brightness, the particle, which means photon, will be more contained. Okay, so we saw about the property of the light wave. So, with the two-dimensional image of the light, setting the time variant, the energy of the light wave is related to the distance how it was propagated and the time where it's propagating or what time it was propagated. So usually means the total or the eigenvalue of the intensity of the light and sinusoidal pattern of the wave that have frequency or periodic propagation. So the K means the wave number. Wave number is stated as lambda over 2 pi, which means at 1 lambda or at 1 cycle, how angular distance it has gone. And the angular frequency means at 1 cycle into pi, how many tumbling or the vibration was propagated. So, before I say, the Einstein shows that the light is a particle, but also not only particle, but also a wave that have periodic function. So why this though? So it is the photoelectric effect. So it can be something like as the vacuum photoelectric. So see, if the light was propagated to the cathode, since it is plus, anode. So when the anode or something metal plate gets light, then we know what is the metal's property. First, have a large free electron, and by this, metal have some equivalent potential energy line, which can be stated as if the metal gets somewhat stable energy from outside, if the energy is strong enough to hold out the electron to be the free electrons, then the electron or finally the current will be made. We know the electron's flow is another side or opposite of the current flow. So making the light propagated to the metal, then the metal will receive the energy from the light or photon. So the photon will meet the metal plate, and finally the electrons will get energy. So see, this black button is the electron. He don't move since he is held by this magnetic or stipulated board. But if I get the power to this button, it can go out. So seeing this button as electron, if I get this one, the more power to it to be free or recite, and this is the free electron. So the whole pie, which means the workout, is the at least energy amount for the metal electron to be free. So if the energy that being beamed or propagated to the metal plate is more larger than the workup, then the electron will be in the metal will be a free electron. So applying this method and the things we said before in this time, see with two-dimensional, the photon meets the metal plate, then there will be two options then be made. First, the electron, and secondly, another photon. The photon was crushed by the metal plate, then electron will be freed. For optional, same as before we said. So, for first, the photon have the wavelength 1, original one, and the secondary made photon have the delta wavelength, which is longer than original one. So longer wavelength means some lower energy. Sorry. So the electron then made will have mass. We know electron have mass of something super small. For I know the electron mass is 1.15 A minus 23. Same like this, don't worry. So super small, and we can feel how it is like heavy. Though since the electron have the mass, since the electron is the mass effective one, we can see the physical theory or equation by this. The momentum power will be velocity, how the fast electron is moving, and the mass by the electron. And the energy, where can be stated as the kinetic energy since it is moving, right? So the kinetic energy of the electron can be 2/1 multiplying mass of the electron and the velocity square. And for the photon, we should know. Photon, in modern physical theory, photon is said that this is mass effective, which can be the mass can be measured. Or some guys say photon is a wave, but it and also can be a particle, but it don't have mass. Actually, I learned something from other professors, but this is quite deep and heavy factor. So at here I don't care about this. So just remember, for the lectures in here I say the photon is the free mass or mass uneffective. So this mass uneffective photon propagate from the metal plate. Since it has got enough energy by the outside, so for photons, same equation but changed. The photon's power can be stated as h over delta lambda. H is the Planck constant, and the energy can be stated as the h multiplying the frequency that change. So the frequency change may be lower than the original one's frequency, since these have more lower energy. Why? They divide the power from the outside that original photon have made. So applying this, we 2D measure with the y-axis. There is no y-axis vector or scalar, so it means the y-axis the momentum is zero. But for f, if there is no something special or particular loss, the total power must be maintained. So y-axis, as I said, is zero. Sorry, this is if the two particles were somewhat mass effective. And this action can be stated, but I said photon is mass ineffective. So setting the mass effective one, the state can be like this. For y, power. For y, how it go with the y, each side of y's propagation power or energy will be zero, so it will be zero. For x, must be same as the original one. So I think applying the pattern that is mass ineffective equation will be stated like this. So welcome back. So the partition of the review point of the video. So third part will be about the Schrödinger equation and why we use Schrödinger equation and what is related to the modern physics atom models of the electron probability stating an orbit. So Schrödinger equation is value time independent. So we say that the wave's energy related equation is stated like this about the sinusoidal pattern. So using the Euler equation, we know that exponential j omega t can be stated like this: cosine omega t plus j sine omega multiplying t. So applying this can be stated like this: the amplitude of the light wave and the sinusoidal pattern. So k, the wave number, and the omega is angular frequency we know without to be proved. And so by this, the total energy is sum of the kinetic energies and the potential energy, which means some positioning energy that have containing saving, and kinetic energy that is moving and using the power. So for the mass effective one, the state can be like this for this equation, and for mass effective one like photon can be set like this: the V means the potential energy, and the h bar multiplying k square over 2m is about the kinetic energy of photon. So see. Sorry. So we can see the electron as wave. So seeing the electron as wave, the wave function saying the pi is the value of the pi of the electron wave and the exponential equation. This is the wave function of electron, and applying this, by second derivations by dividing 2 times df square under the d square pi is same as the k, the wave numbers square multiplying the pi. So the k the wave number square can be stated like this. So, using applying this to the total energy equations, the total energy equation of a wave function. So in here, the electron's wave function and its total energy multiplied is stated like this about the photon. So we can have some question. Why? You say that photon is mass uneffective and electron is mass effective. But here the equation is about the mass uneffective one, right? But I said if the photon gets some energy enough, and if we have some enough energy, then the electron can be stated and also it can be make another photon to be free. So this is why I use this equation. So we multiply pi is about the physical energy and potential energy, and the rest is the kinetic energy. So we say before the scale of the absolute value of the pi, the wave function is the probability that electron can stay in certain orbit for n1, n2 anyway. So using the second derivation of this equation, the sum of zero can be stated as this like this. So we say the probability of electron can be stated is sum of PDF. PDF means probability density function, which means so if there is one case, if there is one 10 people, hey, you did this? No, you did this? No. But someone must have done it. So by the more time and more chance passed, the rate or the percentage of that the person is the one who made it is more higher and higher by the time and the chance pass. So PDF can be meant as that is one case. But some case or some event must have made done it. So the total probability summary is 100%. So PDF can be stated like this. An event that must be happen is here, and there is probability who makes this. So this is the concept of PDF, the probability density function. As density is stacked by stack and stacked, finally it will happen 100%. So anyway, using the applying the PDF. This is the energy where in the atom. So guess here is the one electron, and here for extreme case, the rare state or the energy that electron needs to be a free electron is here, but it's infinite. So what it means? Since the potential energy that need is infinite, the electron can't be a free electron, so it's a slave. So for this case, and here, electron can be stated, yes, but for the case the S is under 0 or S is over A over A, neglecting the layer or interface condition at S is 0 over A. Just say like this: when S is 0 or A is contained at this PDF, right? So for these factors, sorry, electron can't stay outside or inside here. So the PDF will be 0. Or the probability will be 0. But at here, somewhere must be one electron that is taking. So using the PDF, the absolute square value of the wave functions, the intensity, and integrating from S0 from SA is 100%. That there is at least one electron inside. And the equation states like this. And simplify this one, 2a squared That's the intensity of some of the eigenvalue. So 2a squared multiplying 2 pi n under a sinusoidal pattern of sine 2m. So m is at which orbit or level you are stating in a periodic wave of the electron. So for the eigenvalue, a is root 2a under 1. 2a root under 1. So we can see that though this is the barrier energy is not infinite, it seems that the energy, or if the energy is not enough hard to overcome the barrier of energy, work out energy, then the electron can't be free, and it seems like there is no free electron or dark current flow. Yes, for the some practical case, or I hope the case that electron is on slate, but for ideal case, but in practical and from experimental case, that's not. So see, if there is one word, we have some high potential energy barrier, electron is here. It can pass, but let's see. If the word is shallower and shallower and shallower, maybe we can have chance to pass through the word. So what it means, if the electron comes as a wave, if this is super shallow, or the thickness of the word is somewhat small, then what happened? Maybe it can have chance to pass through the wall. Of course, the intensity or frequency can be changed and lowered. But we should remember this: the electron have passed through barrier, so it can occur some dark current or some leakage of current. So it can be related as the concentration of the battery or charging. So anyway, for this factor, just a minute, sorry. Let's see this area for 1 and this area for 2. And let's see 3. But seeing only this one, and the distance is infinity, the y1 can be stated a1 exponential j f m multiplied h bar 2 and the light of speed and the total energy. And for second region's wave function can be stated similarly. F apply h bar square and 2 mass and E minus potential energy. But here, E minus energy is something that relates to the free electron. If the the energy is more higher than the potential energy barrier where electron is free. But for a practical case, for this one, electron can't be free in either case. But I say the quantum tunneling effect here is happened. So if something were higher, but though it is not under the potential energy wave barrier, I think I can pass it. This is the electron 6. So the less energy it is, if the word is shallow, the electrons have probability to pass. So for this vector, how much or how the electron can pass the shallow word is determined by first thickness of word, and second how the electron is, how the word have the potential energy to pass. So the transmission coefficient can be stated so for the case, the root side can be internal side is somewhat minus not positive. So when multiplied to square of the absolute of the wave function, we must use conjugate to get the absolute value. Right? So here a1 square exponential minus 2s and h power over 2m, h power over 2m, and the polarity changes 1. Right? This is the probability of the electron stating in here first. So sorry. So how many the electrons or what probability the electron propagation from the side 1 to side by the wave will happen? The transmission coefficient or the transmission function can be stated like this. Conjugate of 2 and normal 1 of 2, conjugate of 1 and conjugate 1 and what was it? One energy state for 0 and where is F? So how the thing is this? So how the thing is this? If the distance is more closer, this must be more higher. The energy state, the wave function's intensity at position S is more, can be higher. So the transmission coefficient can be more larger. So the probability for the same way, C, that's the intensity, and the 2A. A means the thickness of the wave. So inside the root, though the potential energy barrier where height is quite heavy, since it is inside the root, the thickness of the shallow wall or energy potential wall is more critical. So simply, quantum tunnel will happen where if the energy wall is shallow. Thank you. See you next time.